Hello class, we're going to start by looking at page 21, lesson 1, kick off this year. Going to start by looking at polygons. Looking at 1A on page 21. Uh, Polygon basic definition is simply a figure that has three sides or more and is closed in. And so I drew a couple of polygons here: triangle, three-sided polygon, quadrilateral, four-sided pentagon, and so on and so forth. You have six-sided polygons, and so on and so forth. But I wanted to show a couple examples of what were not considered polygons. You have this shape right here, looks like a cone, and this is not a polygon because of the curve on the top. It's not a straight edge, and so therefore it is not a polygon. And then the one right adjacent to it, this is not a polygon because it is not closed in. So since it is not closed in, it is therefore not a polygon. So polygons versus not polygons. Now a couple of subcategories of polygons. You have regular versus irregular, looking at page 22. A regular polygon, the definition for that is all sides and all angles must be congruent. So right here you have a square. All the sides congruent, same length. All the angles congruent, same measurement. So therefore it is considered a regular polygon. This is an example of a polygon that is irregular. Now an irregular polygon simply does not have all the sides congruent and all the angles are not congruent. Now this one does have all the sides congruent. However, all the angles are not congruent. They're supplementary but not congruent, so therefore that is irregular. And then this one's irregular simply because none of the sides are congruent. The last category on section 1A is convex versus concave. Now for convex versus concave, the definition for convex is where you can draw a point, a line between 2 points, and the only way you can draw that line is where it stays interior. There is no way to draw, if I drew a point out here and connected these dots, well sure it's exterior, but it's not within the polygon. So therefore this is convex. Now an example of a concave is very simple. It looks like it has a cave. But you can draw a line between 2 points within the polygon. These 2 points are within the polygon. But when I connect the dots, the line goes exterior or outside the polygon. So therefore it is a concave polygon. See the shape in C right here, convex. Shape in D, can draw a line through the outside of the polygon, therefore concave. The next section we're going to look at is 1B on page 23. We're going to look at triangles. There's different ways to classify triangles. You have angles and sides. Let's first look at the way to classify triangles by using their angles. In A, we have a right triangle. Now, in order for a triangle to be a right triangle, it simply has to have one angle that is 90 degrees, usually classified with this little box right here. But that is a right triangle. For B, this is an obtuse triangle. In order for a triangle to be obtuse, it simply needs one angle that is greater than 90 degrees. So for example, this angle is 135 degrees. Therefore, doesn't matter what these are, we can already classify this triangle as an obtuse triangle. And then for C, we have an acute triangle. In order for a triangle to be acute, all three angles must be less than 90 degrees. So those are the three ways to classify triangles by angles: right, obtuse, and acute. The next way to classify triangles is by their sides. So we have three different ways here as well. The first way is scalene. Now what scalene means is that no sides are congruent. And we can see that no sides are congruent in this first triangle because of their angles. We have one, in order for sides to be congruent, they must have the same angle measure. So in one angle we have 80, another angle we have 60. Well, we know that in a triangle, all three angles must add up to be 180 degrees. 80 plus 60 equals 140. So therefore, this angle would be 40 degrees, and for them to equal 180, and none of those three angles are the same. So therefore, no sides are congruent. That would make it a scalene triangle. In B, we have an isosceles triangle. In order for a triangle to be isosceles, it has to have two congruent sides. And we label these with these little tick marks here. And so therefore, this is an isosceles triangle. Now, when they are isosceles, just so you know, their angles that are opposite of the side are congruent. I always look at it like a little arrow pointing to its angle. So therefore, since this is isosceles, it means it has two angles that are congruent as well. And then the last triangle is equilateral. In order for a triangle to be equilateral, that means that all three sides must be congruent. And just so you know, if all three sides are congruent, that would mean all three angles would have to be congruent as well, making this a regular polygon. Now let's look at a couple of examples using some algebra here. Using what we know from triangles, we know that triangles add up to be 180 degrees. And so in example 1.1 on page 24, it says to find x and y. And it only gives us this 50-degree angle. Now, how can we solve if we only have one angle? Well, it gives us actually one other thing, and it gives us these two tick marks. Since it gives us these two tick marks, we know that the triangle is isosceles. So therefore, like we said before, if we have two congruent sides, that means we also have two congruent angles. So this one's 50, so therefore x, remember I look at them pointing to where their angle is, x must be 50 as well. Now we know two of the angles in the triangle, 50 and 50, so 100. We know that the angles add up to be 180, so therefore y, it would look like this algebraically. 50 plus 50 plus y equals 180. And then when you solve for that, you would get y equals 80. So you have your two answers there. Let's look at example 1.2, a little bit different. It says find x and y. It gives us one angle exterior to the polygon. Well, this is simply a line. And we know that all lines are 180 degrees. So if this part of the line is 150, we simply need to do 180 minus 150. Therefore, x equals 30. And then you can solve for the triangle. All angles 180, 30 plus 40 plus y equals 180. 70 plus y equals 180, y equals 110. There's your two answers there. And then the last example we'll go over for triangles. Example 1.3, it says to find D, and it gives us no numbers. So the way we can find D is if you know how to classify the triangles going by the tick marks. We know that this is an equilateral triangle. All the sides are congruent. Well, for equilateral triangles, when all the sides are congruent, we know that all the angles are congruent. So if 180 degrees are in a triangle, and you have three measurements that are the same, call this x, but they're all the same, remember. We could call that 3x equals 180. Solve algebraically, divide by 3. So therefore all the angles here are 60. Now that's not the answer, but it gets us to our destination because now we have D and 60, and just like before we know this is a line, so just skip ahead, skip the math. We know that D equals 120 degrees. And those are a few examples for triangles. Okay, we're going to look at section 1C, looking at transversals. Basic definition of a transversal is a line that cuts or intersects two or more lines. We have two lines here. The transversal cuts across both of them. Very basic definition. It can also cut across three lines. It can be as many lines as you want. But another fact about transversals is that they are, we automatically know that the lines are parallel. X, Y, and Z would be parallel when the transversal forms perpendicular angles or right angles. So since the transversal is perpendicular with X, it is a right angle. And for all of these, since they are right angles, then that means the lines are parallel. So that's just something else to know about transversals. Let's look a little bit more at transversals. When you have the transversal cutting across two lines, and we already know that they are parallel. For these, they are not right angles. Well, if they're not right angles, you are actually creating a lot of supplementary angles. And if you remember in geometry, all the different names and terms for those, don't need to know those here. But simply know that you have your transversal cutting across your two parallel lines. So therefore, you are actually creating a lot of small and large angles. Now these small angles are vertical angles. The small and large right here are supplementary angles. So if we know that this angle is 40, and this large angle, well, we would automatically know that this is 140. Well, that is true with all of the other small angles, as long as we know that the lines that it cuts across is parallel. So very easy. So let's look at one example, example 1.4, and let's try to solve here. It says find A, B, and C, and it only gives us 60 degrees. Well, there's plenty of different ways to solve this. You can know that all the small angles are going to be 60 degrees because they are parallel lines. That is the key. So you could solve it that way, knowing all the small angles are 60, or you could solve this knowing that they're supplementary. So they add up to be 180, so 60 plus angle A equals 180. Therefore, angle A equals 120. So all the large angles are 120, and all the small angles are 60 degrees. And that is transversals. The last section we're going to look at in lesson 1 is 1D, looking at proportional segments. Now, proportional segments goes along with the transversals that we just talked about. Something to know, when you have transversals cutting across parallel lines, so we know that these lines are all parallel, because that's what's in the problem. Since they are all parallel, it actually cuts their line segments here proportionally. So we can look at this like so. 2 over 3 is proportional, I wrote 2 over 3, is proportional to 3 over 9 over 2. You could actually do it horizontally as well. You could actually say, one second, you could actually say 2 over 3 this way, notice that right there, is proportional to 3 over 9 over 2. Notice it's the same thing. Now when we solve, just to prove it, when we solve, you could do different ways. You could 3 divided by 9 over 2, well, you would have to divide or multiply by the reciprocal there since you're dividing by a fraction. So that would be, let me get to where you can actually see this. We're going to do just dividing and solving first. 2 over 3 equals 3. Well, when we bring the when we divide by 9 over 2, we multiply by the reciprocal. So that turns out to be 2 over 3 equals 3 times 2 over 9. We simply flip these, and now we're not dividing it, we're multiplying it. So 2 over 3 equals 3 times 2 over 9. Well, we can cancel the 3 over 1, or sorry, the 3 over 1 and the 3 and the 9 can cancel. 3 goes into 3 once. 3 goes into 9 3 times. So therefore we have 2 over 3 equals 2 over 3, so therefore it is proportional. Now the way I would generally do it is cross multiplication. So if I cross multiply here, I would have 3 times 3, that's 9 on one side, and then I would have 2 times 9 over 2. Well, 2 is over 1, so therefore 2 and 2, they're being multiplied so they can cancel. Those cross out. So you're left with 9 equals 9, so therefore it is proportional. And that's proportional segments. We'll just look at one quick example. I don't know, they like to do fractions in these, so we'll look at one quick example and try to solve. Example 1.5, and it says find x. Well, the first thing you have to figure out is what is proportional. I'm going to go vertically. I'm going to go 2 over 5. 2 over 5 equals 8 over 3 over x, divided by x. From there, we simply cross multiply. 2 times x is 2x equals 5 times 8 over 3. So we're at this point. Now, how do we multiply 5 times 8 over 3? Well, the 5 is over 1. Nothing can cancel here or eliminate, so therefore we multiply the top by the top. So 5 times 8 is 40. 1 times 3 is 3. And that still equals 2x. So we're at 2x equals 40 over 3, almost done. From this point, I'm going to rewrite it over here bigger. From this point, to get x by itself, it's being multiplied, so therefore we do the opposite and divide. Well, when we divide, we are actually multiplying by the reciprocal over here. Divide by 2, also known as multiply by 1/2. And then we can cancel there. 2 goes into 2 once, 2 goes into 40 20 times. So x would equal 20 over 3. Kind of a weird answer, but that is correct. And that is the end of lesson 1.